Ladies and gentlemen, it is a great privilege to come and address you in this important conference about libraries in the age of artificial intelligence. It's a big topic. There's much to cover. I would like to start with society's institutions of knowledge and talk a little bit about the scientific and technological revolution we are going through, which is taking us from ICT and new biology into the age of AI. And along with that comes a changing nature of work and also how artificial intelligence views libraries and librarians and what new challenges this poses for librarians and what new tools they have to deal with it. And then I'd like to discuss a few examples of artificial intelligence at work and maybe reflect on the library of the future. So let us start on this beautiful journey. With society's institutions of knowledge, we started with the importance of records and archives. Every society accumulates knowledge over time, both about its history and its current problems and the future, and therefore the maintenance of these records and the ability of institutions like archives and libraries to maintain them become particularly important. In fact, Herodotus, the father of history, used to be very fond of ancient Egyptians because they maintained so detailed a set of records. They were among the earliest to maintain these sets of records, and they kept them for a very long time. In fact, the entire history of humanity is dependent on the keepers of the records. Without them, we would know very little about where we came from and hence where we are going. These cuneiform tablets are also from very ancient period in Mesopotamia, and they used to be written with a stylus into clay and then fired. Egyptians favored papyrus, which was like paper that allowed them to have symbols and writing, and not just limited by the stylus of the cuneiform shape. And they had even drawings and paintings that enabled them to convey much about their lives and their achievements. But the advance of a civilization is based on the ability to accumulate knowledge. Initially, it was in scrolls. Later on, it became codexes. And then Gutenberg taught us to print, and move to print type came into being, and printed books, the incunabula, books published before 1501, and subsequent books moved us from manuscripts to printed books. And these were, of course, the forerunners of modern books, which today we read many electronically. And I tell people not to worry. Once upon a time, we used to read in scrolls, then in codexes, then in manuscripts, then the published form. Now we read electronically. The main thing is the words and the text that convey the meaning that is being passed from generation to generation and from one part of the world to the other. And most countries have now established three kinds of institutions: archives, museums, and libraries to handle all of that. The archives, of course, maintain the functioning of governments, of government institutions, private and public. And the difficulty is always to find the right stuff at the right time, understanding the workflow charts of these institutions to be able to go somewhere. And the accumulation of past knowledge, the legacy, is now, of course, being abandoned from these old types of archives to the digital revolution, where under modern systems of archives, we can find and retrieve almost anything we want. In fact, we can even reinterpret a lot of the information in visual forms. So fast and direct access to desired information is one of the primary functions of these institutions of knowledge. Museums are slightly different. They have been really about collections of objects. The great encyclopedic museums of culture, like the Louvre, the British Museum, the Metropolitan, and other great museums, or museums of natural history, such as those in New York, London, and Washington, which introduce us to past animals that are now extinct or current animals that still exist. And in all of these, they are very popular exhibits, and they introduce the population to part of the ecology in which they live and ecology through which we lived. There's also museums of technology and science, museums to make learning fun for young people, like the Exploratorium in San Francisco, or interactive exhibits that excite the spirit and engage the mind of young and old alike. And now with virtual reality, holography, interactivity, what will museums become? Well, I think the world needs to engage in a rich discussion about the role of museums, from the collectors and the exhibitors of objects to becoming major institutions of science and learning. But above all, of course, our libraries. That to keep our books and journals, we relied on libraries. Public libraries are attached to institutions of learning and research, from Oxford University, the Bodleian Library, or the Library of Congress in the United States. These are, of course, New York Public Libraries. These are all great institutions of learning as well as of custodianship of past learning. The learned journals of learned societies, like the Royal Society or the French Academy or the American Academy are all there. But then came the digital revolution and the internet. And all of that written material went into small hard drives. And this is a picture about which I feel very mixed feelings. It is the first bookless library in October 2010. It was at the Engineering School of the University of Texas in San Antonio, where 425,000 books and 18,000 journals all went online. And then they are now kept in computers and accessible, even more so, through the internet. And the New Library of Alexandria, which I had the privilege of being the founding director for, was born in the digital age, and therefore it shows glimpses of how these hybrid systems between the printed word and manuscripts on one side and the digital world on the other can coexist. Beyond the custodians of past knowledge, there is the producers of new knowledge, and there we're talking about the education system, which prepares the next generation, the research university where teaching and research are combined, and the research institutions, both public and private. And it is these that have given us the scientific and technological revolution we are now witnessing. For we are living through the greatest and most amazing revolution in science and technology. It affects everything. The age of information and connectivity is upon us. It is partly a lot of information, but it's also a fact that for the first time we are totally connected. Well, the digital future is unstoppable. But here I would like to reflect on the fact that data, when organized, becomes information. And information, when explained, becomes knowledge. But we need more than that. We need wisdom. And that requires that societies ensure, and the libraries are the custodians of that, that to the knowledge of the natural sciences, to add the insights of the social sciences and the wisdom of the humanities. And a lot more, of course, reflections and imagination. And our changing world is being totally transformed by the internet. It has been one of the most transformative innovations in the last century. I'm very proud that I know both of the founders of the internet, Vint Cerf and Bob Kahn, who designed the TCP IP, which is the backbone of the internet, and we worked together a long time. As is, of course, the great Tim Berners-Lee, who invented the World Wide Web, WWW, that we all take for granted, and they gave all of that to humanity at no cost. So the internet now crosses all political boundaries, connects us with the speed of light through emails and other connectivity, and creates a true network of global knowledge. And for the first time, we can put at the fingertips of our visitors or our friends or our families these best and biggest foundation of knowledge that we know almost the whole world. Digital technology is here. It is indeed the age of information and the age of connectivity. It is indeed where everything is connected, everything in the palm of your hand. Well, the digital future is unstoppable, and science and technology are advancing at phenomenal speed. Indeed, let me cite four enormous transformations. First is big data, which is now we are adding half a zettabyte or more a day to the information on the internet. And we have other things as well beyond that. So let's take them one at a time. Big data is already here. It raises questions of privacy, cybersecurity, and beyond tomorrow, who knows what other kinds of things we will have to deal with. Augmented reality is already here too, where you can add to what you see through the information that is available in your source banks. And you can, beyond the augmented reality, you can see it sometimes through wearables like the glasses by Samsung and Google. And then there's virtual reality, which is another approximation, which has enormous applications. In fact, virtual reality traffic has increased over 60 times between 2015 and 2020. It is in education, it is in research, it is in medicine, it is in machine design. Interacting with virtual reality is now everywhere. You can analyze airplane engines. You can, in fact, do games. You can do anything with it. And it has come to video on demand as well. It is everywhere. And then there is the Internet of Things, where machines talk to machines without the intervention of humans. It's important to think about that. Part of it is very benign, like cars passing through tolls and don't have to stop because the machine from the car, the tag, talks to the tag reader, and that opens the traffic gate. And the proximity card, which we all know, or these little tiny RFID capsules smaller than a grain of rice, which can be put on your fingertip, smaller and smaller than a grain of sand, less than half a millimeter on each side, and now even to the level of powder, not even tiny grains of sand. But that was just prologue. Now we have the age of artificial intelligence is upon us. From the ICT revolution, we are moving to the age of artificial intelligence. Out of our machines and our software, there emerges a new intelligence. Artificial intelligence is impacting everything, and AI will transform everything. Note that McKinsey Global Institute believes and predicts that AI is contributing to a transformation of society that is happening 10 times faster and 300 times the scale, or roughly 3,000 times the impact of the Industrial Revolution of 2 centuries ago. It is here, it's moving very rapidly, and it's impacting everything. Now, neurons in our brains can have 10,000 connections, providing inputs and signals to thousands of other neurons. And they're wired up in a 3D diagram that's difficult to imagine. And the AI structures simulate the neurons of the brain through what we call deep neural networks, where you have an input layer of artificial that processes neurons that processes these the input data, and then there's the hidden layers that allow for the manipulation of the data, and then an output layer with the results. We have already had many levels of neural networks. More importantly are the parameters that roughly correspond to the synapses in the human brain. So, for example, GPT-3, which has chatbot, gave us this enormous success story, had 175 billion parameters. But GPT-4 is 1,000 times more powerful than GPT-3. So it makes it substantially bigger and more powerful. It can process and produce text more fluidly and more easily. Real brains, however, to this time still remain more complex by far. And they have flexibility factors in it that AI still doesn't possess. But we are getting there. So are we going to be able to move from artificial intelligence to artificial general intelligence, which is closer to the way human people think? Well, we are not yet there, but we are advancing at a very fast pace. Can we test artificial intelligence? Well, the man who invented computers has asked that questions. Can machines think? In fact, Alan Turing, who invented computing machines back in 1936, in 1950, reflected on that, on computing machinery and intelligence. And he devised the Turing test. He says, well, if you sit somewhere and you are discussing with a machine or with a real human being, and you cannot tell the difference between the two, we have to say that the machine has passed that test. Well, ChatGPT has passed the Turing test with flying colors. GPT incidentally stands for Generative Pre-training Transformer. So what do we mean when we talk of artificial intelligence today? It is a simulation of human intelligence processes by machines, especially computer systems, which include learning, the acquisition of information and rules for using it, reasoning, using the rules to reach approximate or definite conclusions, and the ability for self-correction. And thus, AI can handle very complex problems that would defy most humans to deal with. And artificial intelligence, as we said, is impacting almost every field. So, it brings real advantages. They are very useful, for example, not just in classifications of systems, but also in dealing with optimization of very complex networks that are used for electricity grids, for a lot of other things, including supply chains, for example. It can find patterns that elude us as human beings. We look at the same material, we don't see the patterns that they can see. And AI can analyze enormous amounts of information. And as a result, we have now self-driving cars. This is Google's self-driving car in San Francisco. And we have enormous advances in medical assistance. AI identifies bone fractures from X-rays. And more importantly, it can predict where cancer will grow. These two mammograms are 4 years apart. The picture on the left is 4 years earlier than the picture on the right where the cancer has shown up. Again, it was certified by this study by MIT. And therefore, AI is now becoming a central part of the medical practice of the future. And the Articulate Medical Intelligence Explorer, a new type of AI that is applied in medicine, represents an advanced research that improves the capacity of diagnosis far more than a simple clinician unassisted by AI. It is a new form. There are those who feel possible dangers. fearing possible dangers are many, but three of them stand out. One is bias. That means that we human beings have biases, and in much of our work, these biases are reflected. But the appearance of objectivity that can come from a machine that has learned that from us gives an impression that it is neutral, but it may in fact be reflecting the biases we put in. As a result, there's a confirmation bias that goes in. And social platforms can lead to echo chambers, which lead to polarization, and thus the societal disruption. A second concern is lethal robots. By that I mean, we used to have drones, for example, that fire, but where a human being would be in the loop, one who makes the final decision on whether it fires or not. Now this is changing. We have lots of small lethal drones using swarm tactics that can become devastating. And this is the image of the new super fast, super stealthy, super lethal drone of the future that the US Department of Defense has commissioned. But should one give a machine the possibility of killing humans by its own decision without a human in the loop? A viable question. Then there is the question of deep fakes. These machines are now so good they can produce fakes that are so close to the real thing that you can't tell them apart. Now, this is a very serious issue because fake news and lies put our governance systems at risk. Democracy requires the decisions of an informed electorate, not a misguided one. We need to be able to go to trusted sources. But then who can you trust? Who do you know that you can trust? Where is the truth and where are the lies? It no longer becomes possible to do that. And it's not just that lies get spread, but also that truth gets doubted in the process. We can trust no longer, can trust what we see. Now, the new technologies of deepfakes can produce fake videos of someone saying or doing something that are almost impossible to recognize as fakes, except through expert laboratory inspections ex post. But the damage would have already been done. It would be a disaster for elections, for example, and social cohesiveness. If you don't know whether the person that you are looking at is a real person or a deep fake, how can you handle that? So the manipulators of AI can create totally credible images that could tell lies about real people. They can make totally new people out of nowhere. Look at these pictures. These are people who never existed, but that were generated by AI from the millions of pictures of human beings that they've seen. And they are increasingly credible every day. So these are three of the many possible dangers. But how do we guard against such dangers? So we fight it by education. Teach people, I grade everyone, starting with the young, to handle all they see on the internet in a systematic and critical way. This is in Finland, for example. They're being taught very young to learn before you say like or share, to cross-check and reinforce whether something is valid or not. And above all, to learn civility in discourse, rationality in argument. Then we need to regulate the platforms. The giant platforms are now treated as utilities, but should they or should they be treated as publishers? Utilities are not susceptible to any question. For example, a telephone utility. They are responsible only that when you dial the number, you get a connection to the other number. What you say on the telephone is your responsibility. That is if it is a utility. On the other hand, a publisher and his authors are responsible for what they say and publish. And that, of course, affects behavior. And therefore, there is now a great movement among the scientific community to adopt ethical guidelines. For all those working on or with AI, they must help define the realm of acceptable behavior. And that most scientists have now agreed that there's a number of these characteristics for ethical guidelines that include transparency, justice and fairness, non-biases, responsibility, privacy, beneficence, freedom, autonomy, trust, sustainability, dignity, and solidarity. And these are all interpreted in meaningful terms as we go along. Now, for a lot of people, the question is, all that is fine, but what does it mean for my job? Is it going to disappear? Will they replace us? Well, it depends when and where. They already are. Most manufacturing assembly lines now in the world are fully automated. And manufacturing output versus employment, you can see the red employment coming down, manufacturing employment in blue going up, and this is unstoppable. It's because of not only just of the precision, but also because of the costs. Robotic prices are coming down, labor costs are still going up. So as a result, yes, in many fields that will be true. But what about all fields. Well, in general, we think that these revolutions in automation and artificial intelligence and so on will remove 28% of the existing jobs, but will create 35% new jobs. The question is that many of the people who are losing the 28% of jobs are not the best people to take up the new jobs that are being created. So what happens? They get displaced workers and they find no jobs. Well, there's a solution for me. It's easy. Weekend. I remember, I'm old enough to remember, when we used to have only a one-day weekend, 1 day off in the week. Then it became 2, and now everybody in the world assumes that the weekend is 2 days. So it will become 3. And that removes 20% of the 5-day week and takes care only 8% of the 28% have to be retrained. And then all the young people are coming up to fill up the rest of the 35%. So we'll have a 32-hour week instead of 40-hour week. And I think everybody will be better off for it. So now we have to learn to work alongside AI, just as AI has to learn to work alongside humans. And we see this already in a number of places, even on assembly lines. So should librarians be worried about losing their jobs? No. They have to learn to work with AI and do all sorts of things that they could not do before, different things. That is the key. And I'll give you a case study. Let's look at what happened in accounting. Accountants in the old days used to work by hand, doing the calculations and the data entry in the ledgers all by hand. Then various calculating machines were invented, and they just made the accountants' jobs easier. The electronic calculator with the ribbon printout was a great breakthrough. But electronic calculators enabled one accountant to do the work of 5 old-style accountants. So people were very worried that when they became ubiquitous, these calculators would mean that 80% of accountants would be declared redundant and lose their jobs. Not so. In fact, the world hired 5 times more accountants and are doing lots of things that their forerunners did not even dream of being able to do. In fact, this calculating and writing by hand, the demand for accountants has grown from that day to this day and is still growing. This here is the annual growth rate for the demand for accountants. If you look in the last 10 or 15 years, you will see it's growing at somewhere between 6 and 10% a year. And accountants and auditors, the number of new jobs created in employment are more than total average of all the other professions in the world, in the United States in this case. And accounting graduates are also increasing from the universities. So it is not true that the jobs are disappearing, but they learn differently. They learn to work differently. What about AI? Well, here's the advertisement. You can expect 28% average salary growth. The Applied today says this advertisement. So yes, AI is more than a calculating machine, but it's creating more and more interesting jobs in the accounting field. And here's what it says. The auditors eventually veer towards forensic accounting, accuracy validation type the role, rather than sitting with Excel spreadsheets trying to manually reconcile thousands of transactions. That's what AI will now do and give them the chance to reflect on the overall picture. So working with the best technology makes not only the job more interesting, but it gives us more scope for the future. The new technology is not a job taker. It is a job changer, and therefore also a job maker of change jobs. Okay, so how does AI view libraries and librarians? I thought it would be fun to ask these questions. If we ask the generative AI what it thinks of libraries and librarians, well, let's see what it should do. Here's what it says. These are images of libraries that seem to be mostly classical view of a library with old books, but inviting with sunlight there. See, these drawings were made by AI. The library, this is another library. How about the librarian? Well, the image generated for the librarian is quite complimentary. She's efficient, intelligent, and poised. Well, how about what AI should do in the library? This is the fun. The AI wants to sit and read, just like me. Just like me, he wants to sit and read amidst all the books. Isn't that great? He even generated this image for global knowledge, which is not quite what I was expecting, but it shows also some of the current limitations. I emphasize the word current. So, leaving aside this type of fun, there are more serious discussions underway about this topic, and many of excellent books are out everywhere about this. I'm not going to go through them. Some places are already experimenting with robots, while the vastly more powerful AI is already knocking at our door. The future is digital, and AI will be part of it. It will be about knowledge across platforms, systems, and continents. That is the future we're going to. We're talking about mastering the knowledge, its preservation and accessibility, not the physical books themselves. And that poses new challenges for librarians. In fact, the fact that science is now moving towards open science means that you will have a lot more material. As you go from the first draft, you can see the peer reviews, you can see the corrections that were made, you can see the preprint, and then you can see the final published thing. In data science, of course, because of the big data analyticals that are not possible, changes things. Preprints brings into play a lot of different versions of the same work, which we used to take only in its finished final form. The gray literature, which is about reports by the professions that are not formally published as books, become extremely important, and now they're available digitally, as are the PDFs and academic research PDFs. Then our work also involves images and maps and videos and objects in 3D. How to handle all of that is expanding at a very fast pace is part of the challenge of a new librarian's work. But librarians also have new tools to deal with that. I mentioned 4 of these basic tools. New classification systems, databases moving to knowledge bases, and then managing images and maps, and specifically I'll give the example of the Mirador system, and then how to deal with 3D. Let me start with classification systems. Most of the libraries still organize systems the way it was invented in the ancient library of Alexandria by the late Callimachus in the 3rd century BC. In other words, by topic and by author within topic. And so-called Dewey classification, which all librarians know by heart. But in fact, the new map of knowledge, already this beautiful map done by the New York Times in 2009, shows a vast array of different topics that are connected and interconnected in different ways. Eigenfactor tries to allow the users themselves to define the connection. So this is in social sciences between psychology and psychiatry and economics and so on. And the thickness of the line defines the strength of the connection, and the size of the circle shows how much self-reference there is. These are the natural sciences. But the new digital revolution changed all that by allowing the creation of huge searchable databases and powerful new search engines. So that changes how we will interact with knowledge, going from hypertext, being able to move from one place to the other, to the semantic web, which goes beyond objects, to connections between objects, and create a living, vibrant, changing, interconnected knowledge base all across the world, where everybody is accessing, taking the knowledge, studying it, and adding to it. And this is going on today. Now that requires that we also move in our thinking from databases to knowledge bases. What do I mean by that? Well, enabling access to knowledge, creating knowledge bases out of databases. And we have to also deal with the preservation of digital content, technical and physical obsolescence that come with it, but that's another discussion. Let us just think about knowledge bases. How do we move from databases to knowledge bases? Well, it requires the ability to identify concepts, meanings, and contexts, and allows disambiguation. It also allows for searching way beyond keywords. AI can not only accelerate that to an unbelievable scale, it can also identify concepts and items that are not specifically mentioned in the text being reviewed, even when no keywords are provided. It can be trained to do all that better and better. So when libraries build a system, a digital database system to store and retrieve their collections and use some of the best knowledge bases available through commercial specialists today, such as UNO. UNO is one of many, so I'm just not particularly recommending it, but it's one out of many. And some of the private companies that do this work if you want to. But there are many more, and I'm not suggesting any particular company. But what they do is they are able to move from traditional search engines to discovery systems. So traditional systems, you know what you're looking for, and you have simple questions and straight answers. But today's ecosystem is when you don't know what you're looking for, and you have open-ended questions, and you get complex answers. But that is something that the modern knowledge that is multidisciplinary and touches many complex fields and maybe new fields requires us to make maximum use of it. So different designers can tweak their designs to produce more focused results for particular things. So let's take an example, the disambiguation of the word jaguar. Well, here it is. Concept is an atomic unit of information composed of one or more definitions on one or more topics. So we can look at the jaguar and think of it as an animal, and that takes you to nature, zoology, and wildlife, or you can think of it as a car, and that takes you to engineering, car marketing, and brands and the like. So the same thing can be much more complex also if you look at depression. Well, there's meaning in geology, there's meaning in climatology, there's a meaning in economics, there's a meaning in sciences generally, there's a history, there's also a medical meaning and a meaning in business as well. So mood and physiology and a major depressive disorder in medicine. So all of these have meanings. To extract the new concepts from random documents, it's very important to be able to do that. So the building a knowledge base involves the extraction of these new concepts from existing texts. The term 3D printing, for example, in the text here, you won't have time to read it, but if you were to read it, you would see that it is not mentioned in the text itself. Algorithms can understand meaning, what is this being, the text is being written about, and therefore they can also understand context and meaning. And finding a hidden content missed in the traditional search, for example, looking on the example on the left for the word zero hunger doesn't exist, and on the right, the word gender equality are not mentioned in the text. But in both cases, the AI was able to identify it and link it. As a result, the libraries of the near future will have to expand their work from databases to AI-enabled knowledge bases and focus on a reconfigured set of tasks. What new tasks? Well, these kinds of tasks. Digital Scholarship Center, research data management, digitization, research enablement, teaching and learning enablement, collections, spaces, entrepreneurship, self-service, all these functions far more than simply classifying books and finding them and putting them again on the shelf. An interesting current application of AI that shows how it can help librarians is happening in the Library of Congress. This is the Library of Congress in Washington, D.C. And what we have is the Library of Congress has a complete digital record of all local newspapers in the United States. And as a result, by sending the AI across, it can look at all these newspapers and identify within them particular newspapers and identify the pictures in these newspapers. The pictures then are identified and copied and tagged in relation to where the source was, the date at which it was. As a result, the AI, by going through the digital files, is building a magnificent new collection of historic pictures of the history of the United States that's taken from all the local newspapers as well as the international newspapers where the pictures appeared from the time that they were published. And that is just the beginning of what we can do and can expect in the next few years. Now, managing images is much, much more complex than that simple example from the Library of Congress. Let's look at the Mirador IIIF. This is really about dealing with images and maps. What does it stand for? The International Image Interoperability Framework. It's a case study, and since 2018, it has been launched by Michael Keller and Stu Snideman of the Stanford Libraries, and this is an amazing thing. Initially, the images are fundamental information carriers from the cultural heritage, whether it's music, or it's newspapers, or it's manuscripts, or it's paintings, or it's graphics, or it's even pictures of sculptures, and so on. But image delivery on the web is hard and slow and expensive and disjointed and locked up in silos. So here comes the framework the IF can build. First of all, you can have deep zoom with large images. You can cite and share regions of interest, for example, First World War pictures. Or you can compare images that are taken on different things, from the sea lion on the left to the medical X-ray on the right. They can be compared. Or you can look at comparisons from the Bodleian and other sites, so you can search across sites. And sometimes manuscripts are lacking pieces that are found in different libraries. That allows the framework to bring them together and complete the missing pieces together. You can also overlay maps, much more detailed, modern maps on much older maps of the same area. You can also annotate as you go along, and you can do crowdsourcing and find a specific meaning for particular old pictures. Then you can find ways of displaying things. At the McMillan Museum in Boston, for example, manuscripts are on one side, and the more extensive presentation that connects what's in the manuscripts on the left to other sites around the world is found on the right, and visitors can use a touch screen to get them. And we can see many other examples of that. So how does it work? Well, it takes actually many different applications and from image servers all over the world, and allows the crossover from one to the other so that you can do application programming interfaces between what is available someplace, and you can then try to isolate certain parts of it and find a structured way for connecting the various systems. You can export and embed in third-party apps, customize the apps and annotate them from the data source itself, and you can do that across all of the different applications. As a result, the main thing is that we create a global framework by which image-based resources, now we're talking images, books, maps, scrolls, manuscripts, music scores, etc., from any participating institution can be delivered in a standard way via any compatible image server for display manipulation and annotation in any application to any user on the web. And you can analyze books. You can also look in 3D over certain types of images like medical or archaeological things. And if you have access to members who have, for example, the detailed analysis of this Vermeer painting, you can also get it where you are. It doesn't have to remain only in the labs of the museums that have it. And that simple now exists. It has the three primary functions: to load and view and share, and embed this material how using. So it's a community that develops shared APIs, implements them in software, and exposes them in interoperable content. Any kind of content, paintings, maps, manuscripts, photographs, scrolls, sculpture, sheet music, that expands enormously the role of librarians. And that first consortium has over 1 billion images from 200 plus institutions. It was started by the Stanford libraries, as I mentioned. Millions of digital objects. It's really a revolutionary promise for the future. And along with that comes the dealing with 3D beyond interaction. The digital revolution promises to take us into an interactive and multidimensional reality. From conventional virtual reality to the richer metaverse, immersive and possibly multi-signals. We'll see. But at any rate, it is a promise that's not yet done. But we do know that 3D imaging is becoming real and is affecting people in how they deal with also text and the management of text. That can only be done with AI. So remember that our records include films, pictures, audio and video, text, some of which was never written on paper. We already have our archives full of multimedia materials, and what AI can help us see and interact with in many new ways. It is an exciting time to be a librarian. Now, let me give you amazing examples of AI at work. The first is reviving the legacy of the past. Here we are using AI to retrieve information that was burnt in 79 AD in the burnt scrolls of Herculaneum. In 79 AD, Vesuvius erupts, destroyed the city of Pompeii, which is quite famous, but also of Herculaneum, which is right next in the Bay of Naples. And the Herculaneum had a big villa that had a huge collection, so-called the Villa of the Papyri. And the people, of course, were all immediately destroyed by the lava, but the many other parts, the great villa, which we see here, has been destroyed, and it had a beautiful library. And the question was to know what kind of books were in that library, scrolls in the time. Well, it turns out that there's more than 1,800 papyri discovered in the 18th century, and that they've been carbonized when the villa was engulfed by the eruption of Mount Vesuvius. Here is what the scrolls look like. They look like pieces of logs. Efforts to try to unroll them resulted in breaking them up, and you could not unroll a scroll. Tiny little pieces broke off. Some tried to analyze those little pieces. Very small, not very effective. Maybe one word was found here and there. And then in comes a young group of students competing for a prize using artificial intelligence and scanning and getting these CT scans and being able to read the slight distinctions between the lines that you see here, which are the rolled scroll. They were able to solve the puzzle, or at least for parts of it, to be able to distinguish the actual texts. And here they are, how they were produced by artificial intelligence. No way a human being could do that. Finally, a tool that helps us deal with that. And as we advance more in the development of AI, we can expect much more in the future than all of this. And here we have another enormous success story, brain-machine interface. Can machines read the activity of the neurons in our brain? And the answer is yes. We have, because of paraplegic patients who cannot talk, who cannot express themselves, but they can think, we can now find ways of reading their neurons, and that translates into the ability to write text, even by thinking of complete words. And more amazing developments are now coming on. So here, a person sees an image. We take a brain scan of that person and show the brain scan to an AI, and the AI recreates the image that the person saw. That's amazing, but it can find images in the brain scan. So the top 4 images are the images shown to the person. The bottom 4 images are those that have been deduced by the AI from reading the brain scan. Some inaccuracies, but in general, it is quite remarkable. And we think this is still in its very preliminary stages. So far, this has been tested on about 4 or 5 persons. It will undoubtedly get much better in the future. This was published in Science in March of 2023. And AI also gives an enormous boost to science. It allows us to solve problems like the double pendulum of the stock market, which are known as chaotic systems, which are systems that you cannot easily predict. And it can do that very well. Look at the AI for the AlphaFold did for proteomics. Now, what are proteomics? Well, proteins are very complex molecules. They look like the picture you have here on right. And any misfold in that protein affects the ability of the protein to function. And we, as living creatures, rely on the proteins in our body to do all sorts of things. They're incredibly complicated in 3D, and the misfolding can create problems, as we saw, for example, with the mad cow disease. And Google's DeepMind subsidiary, AlphaFold, brought AI to the task of predicting the 3D structures of the protein, and it was able to do 200 million molecules in 1 year. Normally, it would take an average graduate student 2, 3, 4 years to do one protein. So you can imagine it's almost 1 billion years of graduate student research. And all this information is now made openly available to all researchers in the world. It's a wonderful breakthrough, and it will help develop many treatments and diseases in the future. And as a result, we're talking now of sharing of knowledge, which is more than just a publication in an article or a book. This is enabling further research to take place. And what's happening right now, we're doing this to predict DNA, RNA, and other molecules and how they interact, which will also help in drug discovery and research, and will help, of course, researchers to have access to all this information. So what next? Who knows? But I'll say a few words about the library of the future. Enabled by AI, the library will be the gateway to a network system for global knowledge management. Global knowledge that is generated by all and retrievable by all. And libraries will be the mediators of that, working with the artificial intelligence. And libraries are the quintessential knowledge-based institutions, and they should not be worried about new technologies. They should be able to master knowledge management and give our organizations the tools to be part of the global system of global knowledge that is emerging. Here are 7 things that an institution should do to effectively use AI in its operations. First, when you try pilots, be honest with yourself about what worked and what doesn't work. Cut down on experiments and move on things that are working well. Then think that you are not looking at just a piece. You want to see how the pieces fit together so that you have a system that is functioning. And only the librarian that is running the library will know what kind of system they really want. And before you get too carried away, try to have a good handle on costs. They're coming down very rapidly, and some things are for free, but still commercial vendors can sink you. Then you need to tame the proliferations of tools and tech. Many people in your institution, one will want to do this, one will want to do the other. You want to give them a chance to work on that. But create teams that can build value, not just models. So you don't want just tech teams. You want real librarians who are concerned with the function of the library, working with tech specialists to bring added value to the system you go for. Go for the right data, not the perfect data. Somebody who tries to design a perfect system and then cannot fill it in because there are bits of pieces that are missing in it. You have to interpolate them and so on. Try to find the right level of specificity that you need. And then, common argument, reuse it or lose it. In other words, if you have something that works well, but only for one example, and you can't reuse it on other examples, then don't waste your time on it, move on elsewhere. Recall, science and technology are advancing at phenomenal speed, and AI will soon be built into all our devices. Generative AI is still in its infancy, and change is happening with incredible speed. We will not compete with robots or artificial intelligence. They will seduce us. We will invite them into our lives. For example, remember the smartphone. Who can make do without their smartphone today? And we shall expect very soon driverless cars. And then who will be saying, I want to drive a car anymore? And robots with AI will become our new partners. ChatGPT is already showing us. It will change, but it is there. And again, what's next? Who knows what's next? But I can tell you one more thing. We're already moving from text to voice, And you saw with the brain-machine interface that we can also move from voice to thought. Voice-activated personal assistants are prevalent, from Siri to Alexa and so on, but brain-machine interface is advancing rapidly. We saw that somebody could think about words and produce typing characters at about 90 characters per minute with 95% accuracy, with just by imagining handwriting the words in question. So BMI could lead to constant, seamless interaction between humans and their machines just by thinking, not even voice commands. That is probably a next step. Ladies and gentlemen, the digital future is here. We are just at the beginning of the age of quantum computing, robots, and artificial intelligence. It promises to exceed all our imaginations. Clearly, we are witnessing the dawn of a new age. So let us embrace it. Thank you.